Okay, so in this section, we are going to look at machine learning workflow. What we really want to focus on is not the specifics of the algorithms that we're going to start building, but we're going to understand what are the steps we need to do to prepare our data, to choose a model, train a model, and then ultimately validate it and deploy it. What you'll notice is that these kind of machine learning workflow is common across most of the methods that you use. So it's good to get into the idea, a rhythm of understanding the steps that it requires to build a good machine learning model. Okay, so just as an overview, kind of looking at the process, I would say that this is not just a hard and fast recipe about how you build machine learning workflows, but it gives you a good idea about kind of the patterns which you should expect. So taking you through this diagram, what we'll be understanding first is we start in the top left-hand corner, understanding about data preparation. How do we prepare our data? Once we have our data prepared and it's clean and it's in a good form that we can use, we need to make decisions about what's important in our data. We call this feature representation. And so basically it's distilling what the important inputs are for our problem. Once you're at this stage, we would naturally choose a model. So these could be different types of algorithms. Often, as we'll talk about, that's more than one type of algorithm that we'll be looking at. We'll train a few and then we'll probably pick the best, or even take an ensemble through with us. Once we've got a model that we'd like to fit to our data, we go through the training process. Once we've trained it, we then will probably have held some data back, and we'll go through a series of validation steps to make sure that our trained model can generalize well to unseen data, because that's the ultimate aim of machine learning. Once you've done that position, you can use with care, but often it requires tweaking of each of the different stages of this. So it's not always just a one-shot process of building. We might try a different model. We might think about a different way of training it. Maybe training hasn't gone so well, and we can identify that. And maybe we need to explore some parameters, hyperparameters, about how we set the training process up in a different way. Equally, we might say that we need to collect more data. We just don't have enough data to build a good machine learning model for this problem. And then we can use our knowledge of what we've trained so far to do something called active learning. So we can go back and strategically collect more data. And another option is we can look at, instead of collecting more data, we can think about representing it in a different way. Do we need to include more variables? Do we need to include less variables so we can be more data efficient? And so even though you'll notice a similar trend in all the examples that we show you, that it's kind of this data preparation, feature representation, choose a model, train it and validate it, you'll see different nuances for different algorithms. So don't get set in stone about this, but use as a guide for understanding the steps that you need to take to build good models. So particularly in this section, we'll have a number of explainers and examples on how many is it? 5 topics. Okay. The first one will really focus on that top line of the process. So all the boxes in green that I showed, that's around data preparation. So how do we build with outliers, noisy data, misaligned data, all the annoying things that real world data comes in. We will talk about unsupervised learning algorithms for representation. So how we simplify our data sets without losing information. And then we will go through the idea of model selection briefly. Once we've done that, we will take a real focused look about training. So we'll have an overview of training and tuning. So what we mean by optimization of the parameters of the model, what we mean by tuning of hyperparameters of the model, and why are they different. In particular, we'll then have detailed explainers about what we mean by a loss function. Loss function is essentially a measure of how well your model does against your training data or your validation data. And then we'll also look at training curves, which is an important part of training. They give us insight to whether our model is actually trained well. And then finally, a really important part of machine learning, particularly in areas that digiLab look at, often the machine learning algorithm is used in safety critical applications. So we really need to be sure that the model is good. And will it generalize? Will it give safe predictions? And there's a whole suite of techniques, plots, metrics that you can pull out of your model to gain confidence in its ability to generalize. So really important section. Quite high level in terms of understanding the main principles, so has very little maths in it, and we'll get into more sort of details of a particular algorithms in the next section. But yeah, a really good takeaway of this is really understanding what people mean when I've built a machine learning algorithm. These are the constitutive parts. Great, let's get to it.